If you recall, we can calculate the standard cell potential for any electrochemical cell. So in this video, what we're going to do is we're going to connect the standard cell potential of an electrochemical cell back to Gibbs free energy in order to be able to make some predictions about spontaneity. So standard cell potential for an electrochemical cell is calculated by taking the E0 value of the cathode minus the anode. And if we remember, cathode is where reduction happens, and the anode is where oxidation happens. Now, how does this connect to Gibbs free energy? Well, if the E0 of a cell is a positive value, we know that that's spontaneous. And that relates to Gibbs free energy because Gibbs free energy is also going to have then a negative value indicating that it's also spontaneous. We have the opposite. If delta or the E0 value is less than 0, that's non-spontaneous. So if we were to calculate delta G for that system, it would also be non-spontaneous. We can use an equation to relate these two values together then, where delta G, or the Gibbs free energy, is equal to negative NF E0. So N is the amount in moles of electrons that are transferred in the balanced equation. F is Faraday's constant, which is a constant value given to you. And then the E0 of the cell is something that you can calculate from data tables. Really important to keep in mind here that the answer you'll be given from this calculation results in units of joules per mole. So you will want to convert that to kilojoules just to put it into more sort of conventional ways of reporting delta G values. So let's take a look at an example. How do we use this equation here? I'm actually going to change this to something that we can just look up in our data booklets in terms of values. So I've got tin reacting with 2 iron 3 plus ions to give us tin 2 plus and 2 iron 2 plus ions. We can identify oxidation and reduction pretty easily just by looking at oxidation numbers. So iron going from +3 to +2 is reduction. And then tin going from 0 to +2 is oxidation. So that tells us we could go look up these values in our E0 value table. If we look up the iron reaction, so that's reduction, that's going to happen at the cathode, and that is an E0 value of +0.77. And then at the anode, we have oxidation, so that's our iron reaction. And if we look that value up in a data table, it's negative 0.14. So let's set up our delta G. Our delta G equals negative NF E0. We need to figure out what N is. So if we take a look and we pulled out and teased out our two half reactions here, we'd have tin going to tin 2 plus 2 electrons. And then we'd have 2 times the iron 3 plus 2 electrons to give us 2 iron 2 plus. So 2 moles of electrons are essentially changing place here within this reaction. So our negative N is going to be negative 2. Faraday's constant, 96,500. And then our E0, we're going to do cathode, which is 0.77 minus our anode. Okay. And so that's going to give us a delta G value of negative 175,630. That's in joules per mole. So we want to convert that into kilojoules per mole. Just going to divide by 1,000. And I'm going to round it off to a whole number just so it looks good. So we get a delta G of negative 176, which means that this is spontaneous. And we can tell that as well because our E0 value of our cell is also going to be a positive value. So they are both kind of confirming with each other that this is a spontaneous reaction. But we've now got a delta G value to go along with that. That's it then for this video. We'll see you in the next one.